A couple months ago, I got the idea to custom build a scuba weight that could be quickly attached to a scuba diver if he needed more weight. After doing a couple pool dives with it, I realized it was an entanglement hazard and we needed to make it smaller. The first thing I'll do on the redesign is get a 3D version of the bolt shackle. The major difference between version 2 and version 1 of the lead weight is version 2 is going to be about half the weight, and it's going to be much less of an entanglement hazard. The final product of the lead weight will have much more of a pill shape, and the shackle will be inside of the weight as opposed to sticking out of the top. Because I made a CAD version of this bolt shackle, I'm able to properly model it of what it's going to look like inside of the lead weight. The next step of the project is to create a small gap where the D-ring of the scuba diver will fit inside of this bolt shackle. The end result is to cast this in lead. In order to do that, I need to make a plaster mold. In order to make the plaster mold, I need to print a mold for the plaster mold using PLA on my 3D printer. In order to properly get the two halves of the mold to line up, I'm going to be putting the spheres in place. On one side they'll be hollow, and on the other side they will be solid. I will also need a sprue for the lead to go through, along with an air vent. I'm also going to need a small hole in the PLA mold in order for this snap shackle clip to fit into. Because each half of the mold is slot specific, I'm going to put a right on one side and an L for left on the other one. Since I won't be needing quite this much PLA printed, I'm going to make the bottom half disappear. Once the CAD files are done, I'm going to take it to the splicer, then send the print over to the 3D printer. A couple hours later, we have our parts properly printed. Instead of making a box like I did last time, I'm going to 3D print the back part of a mold. I will be using petroleum jelly as the mold release, so the plaster will not stick to the 3D printed piece. Temporarily hot glue everything together. Now it's time to prepare the plaster. In order to cut down on the dust, I use this little piece of cardboard. With this plaster setting up in about 5 minutes, I don't exactly have a lot of working time to get this accomplished. In order to remove as much air as possible, I'm going to be using this little massage tool to vibrate the plaster down into the mold. Hopefully we got as much of the air out as possible. Let it fully set up, then a couple hours later we take a knife and remove the glue from the mold. Unfortunately, due to my poor mold design, a few of the walls were a little bit too thin, so I had to whip up another batch of plaster and reinforce those. Let it finish curing, come back about 20 to 30 minutes later, and remove it from the mold. Unfortunately, one of the indent marks didn't properly turn out. As you can see, it stayed in the bottom part of the mold, but honestly, we only need 2 of these 4 to work. For the next step of the process, we're going to need to drive off as much moisture as possible. So I'm going to take these outside, throw it in a toaster oven. Next, I need to cut off the bottom portion of the bolt snap. This piece right here will be pretty much fully embedded in the lead. Head outside to check on the molds, and you can see from the fogging on the lens, we've still got some moisture in there. I definitely don't want any lead inside of this shackle, so I am going to pour a little bit of plaster in there. The plaster will be 100 times easier to remove than the lead will be. Unfortunately, due to my limited CAD skills, I was unable to fully 3D print the mold the way I wanted it, so we are going to need to remove a little bit of plaster using this knife. If this was a mass production item, I would definitely take the time to do it, but since I'm just going to be doing a couple of these, I will just simply carve them out by hand. As you can see, the 2 halves of the mold properly interface with each other, and now we need to hold them together permanently in order to do the lead pour. And for this, the best way that I can think to do it is basically make a plaster cast around them. I'm not exactly sure what this stuff is called here, but I know it's used in sewing projects. Once I've got this piece thoroughly saturated in plaster, I'm able to wrap it around the mold, and it holds everything together perfectly tight. Once I'm finished with the mold, I'm going to naturally let it set up overnight, and then the next day I'm going to stick it in the toaster oven for about 6 hours to drive off as much moisture as possible. And with this attempt, I will be trying to do 2 lead molds at the same time. I will be using propane to melt my lead, and this part you definitely do outside with plenty of ventilation. The lead that I'm using is actually recovered from cast iron sewer lines, and when it burns off the pitch from the oakum, it definitely gives off an interesting smell. We'll flux the lead, then remove as much of the dross as possible. Once the lead is ready to go, we're going to remove the 2 molds from the toaster oven. We're trying to use the toaster oven to drive off as much of the moisture as possible. You definitely don't want any moisture in the mold when you pour lead in, because the moisture will turn immediately to steam and blow all of the lead out of the mold. As you can see here, we definitely still had some moisture inside the mold, but we were able to make it work. We'll come back a couple hours later after the lead has had a chance to solidify and cool down, hopefully to about room temperature. I was kind of worried these plaster molds wouldn't hold up, but I don't see any lead leaking out, so I'm still hopeful everything turned out properly. And unfortunately, these molds are one-time use only, and in order to get the lead out, we need to break the plaster. The first lead weight turned out okay. Now we need to check on the next one. Overall, I'm not unhappy with how these 2 lead castings turned out. Now we need to finish cleaning up these pieces. We're going to remove all of the lead pieces from this plaster, throw away the plaster, and cut off any extra pieces of lead from the castings. On one of them, I did have to break out the hammer and chisel and persuade a little bit of the lead to come off in order to properly operate the bolt snap. The easiest and safest way to remove the plaster from the lead that I could think of is putting the 2 lead weights in plastic bags and throwing it in the ultrasonic cleaner for 15 minutes. And as soon as we remove the lead weights from the plastic bags, it's all nice and shiny and the plaster has been removed. On one of the pieces, we did have a little bit of plaster on there that we needed to scrape off, but all in all, these turned out perfectly. Or at least good enough for what I'm trying to do. But now the only thing left to do is to take these scuba diving. I brought them to our monthly training event, and I was able to get some good feedback from some of the other scuba divers. At this point, I'm not quite sure if there's going to be a version 3 or what further improvements can be done.